Welcome to Autism Mathematics. This is where we help students to find their feet when it comes to the basics. I have a special package for you today. Before I start, if you have not subscribed, kindly click on the subscribe button. Or to support this project, you can call the number on your screen, 0242 30 7846. Thank you very much for your support. Now let's start. I am on a series, the 7 building blocks of mathematics. The first one was arithmetic. The second is algebraic expression. And under algebraic expression, we are looking at factorization. And so far so good, we have considered about 3 cases, 3 ways of factorizing an algebraic expression. The fourth one, and which happens to be the last one, is difference of two squares. Example, if you have a squared minus b squared, this is a perfect square. This is also a perfect square. If you have been watching my videos, I've talked about this difference of two squares before. This is a perfect square. A, you can write it as a times a. Then b, you can write it as b times b. So we are looking at if you have two squares and then you have this subtraction sign in between them, we call them difference of two squares. So when you have such an expression, how do we factorize? So let's look at some examples here. Factorize the following expressions. The first one is x squared minus 36. Before you can use this method, always make sure the first term is a perfect square and then the second term is a perfect square. If you are able to establish that, then you go ahead and rewrite it as x squared. S squared can be written as x all raised to the power, and then 36 is a perfect square. We can rewrite it as 6 all squared. Now to factorize, you pick one of these x, then you pick 6. So you combine them with plus in one bracket, and then you combine them with minus in another bracket. That is all. Now let's look at the next one. The next question, x squared minus 1. So first let's check if they are perfect square. So x squared is a perfect square. It is a perfect square. Now if we are able to establish that one, then we can rewrite it as x all squared minus 1 all squared. So as we did in the first example, you pick one x, you combine it with plus, you combine it with 1 with plus sign, and then the same x, you combine it with minus sign. That is your answer. Let's look at the other example. But example 3, so far I've solved 2 examples. Just pause the video and then solve example 3 and then 4. And then after watching the video, you cross check with your answer. Example 3. We have 4x squared minus k squared. Please don't forget, always check if the whole term is a perfect square. 4 is a perfect square because 4 is the same as 2 times 2. X is also a perfect square, or x squared is the same as x times x. Now let's come to the second term, k squared. K squared is the same as k times k. So we can rewrite this one as 2x all to the power 2. So when you expand it, so 2 squared will give you 4, and then x will be x squared. And then we write k squared as k all squared. So which is equal to 2x, you pick 1, then you pick k, plus k in one bracket, and then 2x minus, very simple one. Let's look at 4. 5 minus 20x squared. Okay, so let's check the first term. The first term is 5. You ask yourself, is 5 a perfect square? No, 5 is not a perfect square. And then let's look at the second term. 20. Is 20 a perfect square? No. And then we check x. X squared is also a perfect square. Now you ask yourself, what can I do? So the examples that we have gone through so far, all the expressions in the terms were perfect square. So when some of them are not perfect square, you ask yourself, can I factorize first? Use common factor to factorize before to use common factor to factorize first. So we have 5 here and then 20. Know that 5 can go into 20, so we can bring 5 out. I want to bring 5 out to be left with 1 here, and 5 into 20 is 4. Then you bring your x squared. So let's check what is in the bracket. So 1 is a perfect square, 4 is also a perfect square, x squared is a perfect square. So we can now apply the difference of 2 squared. The 5 is there already. So 1 all squared minus 2x all squared. Then you bring your large bracket. So you have 5 times 1 plus 2x. Now let me say this. You can interchange it. So let's bring minus first. 1 minus 2x times 1 plus. Always you have to open your eyes. You have to open your eyes. Let's look at the next set of questions. Yes, we have 2 set of questions on the screen. So as we did in the previous session, pause the video, solve these 2 questions, and then compare it with my answer. So we have question 5. 12y squared minus 3m squared. So let's check. Is 12 a perfect square? No. Is y squared a perfect square? Yes. Is 3 a perfect square? No. Is m squared a perfect square? Yes. So what you can do is to ask yourself if you can factorize it first by the use of the common factor, so that you get a perfect square. So 12 and 3. 3 can go into 12. So you bring 3 out, and 3 into 12 we have 4y squared minus, you brought 3 out, so it will be left with 1 times m squared, perfect square. So you can now use the difference of 2 squared to factorize. So we can rewrite 4y squared as 2y all squared minus, so you have your 3, so then you pick one of each. So 2y minus m, yes, in one bracket, and then 2y plus m in another bracket. Let's look at question 36. Let's look at question 6. X squared minus 100 y squared. So first you have to check 36, is it a perfect square? Yes. X, is it a perfect square? Yes. X squared. 100 is also a perfect square. Y squared is also a perfect square. So we can rewrite it as 6x all squared. It's the same thing. We have not changed anything. And then this one will be 10y all squared. Can pick one of each. 6x plus 10y in one bracket, in another bracket 6x minus 10y. So let's also look at the next set of questions. Once again, pause the video and try to answer this question. We have x squared minus k. Now, I have told you before you use difference of 2 squared, you have to first check if they are all perfect square. Is x squared a perfect square? Yes. Is k a perfect square? No. Now, which means that you can't use difference of two squares. But if you still want to, you are asked to factorize, then you have to find a way of rewriting k so that it will be a perfect square. And this is how you can rewrite it. So x all squared is the same as square root of k all squared. Now square root of k will take care of the square root and you still get your k back. So anytime you want to use difference of two squares and one term or one factor is not a perfect square, this is how you can rewrite it. You always put that expression under the square root. It could be a number, it could be an expression, it could be a variable. You put it under square root. When you square it, you still get the same thing. So this time, so you pick x minus square root of k in one bracket, and then in another bracket x plus root k. So we have the same situation for the last question. Same situation. So 2p squared minus 9q squared. So let's check. 2p squared minus 9q squared. So you first have to check, is 2 a perfect square? No. P squared? Yes. 9 is a perfect square. Q squared is also a perfect square. So as we did in question number 7, if this is not a perfect square, we can rewrite it as square root of 2p all squared. When you simplify, you still get, because the square will take care of the square root and you still have the same expression. And the next term, they are all perfect squares, so you don't have a problem. So you can write it as 3q all squared. Let me remind you, this p is not under the square root sign. So you have square root of 2 plus 3q, and then square root of 2p minus 3q in another bracket. You can even rewrite it as p plus 3q in another bracket minus. Where we end. Thank you very much for watching this video. We have looked at all the 4 ways of factorizing. So the next video that is coming out is how we are going to apply difference of two squares. Keep watching. If you have not subscribed, just subscribe and support this project. See you next time.